Guys, Mr. Bowman here. Today's learning objective is in green, and we are learning to use trigonometry to determine the internal angles of right angle triangles. Key thing, we're carrying on with trigonometry from the previous lesson, and there'll be a lot of similar concepts. We're now going to move on to, bad line there, we're now going to move on to, well, how can we use trig to find the angles instead of just the sides? So just to recap, the four-step process we need to use trigonometry. First thing is you need to label the sides of your triangle. So I'm just going to write label there. After that, you need to find out what formula you want to use. And then step 3, you needed to substitute. And then step 4, you did need to use a little bit of algebra to go ahead and solve to reveal your final answer. Now this process is the exact same. It doesn't matter if you're looking for sides or angles. The only thing that will be different is the step at the very end. When you solve, there is a slightly different and new technique we need to know about to solve this type of question. Okay, so I've got 2 examples that have popped up, and we're going to follow the first 3 processes from the previous video. Just want to note, to help us remember the formulas, don't forget sa, ka, toa will be relevant in that determination as well. So let's get into labeling. We'll do this question on the left first. So there's the right angle. The opposite to that is the hypotenuse. There's the given angle. Opposite to that is the opposite. And just noting this time around, I'm using the given angle a bit loosely. We haven't been given it, but we are interested in this angle. Therefore, it becomes the opposite of the angle that we're interested in. And the final one down the bottom, that there's the adjacent. The same process now applies. Now, 2 of those 3 sides of the triangle we care about. 1 of them we don't care about. We're given the hypotenuse. We're given the opposite. That means we don't care about the adjacent. That means the 2 sides we care about are O and H. And if you go down to our sa, ka, toa, it's the saw of sa, ka, toa that we care about. So our equation, sine angle equals O over H. So we've done the labeling and we've done the formula. We're now going to substitute. So we're going to put all 3 things, the x, the 8, and the 3. All of them have to go into that equation. So that's going to be sine x, and x, because we don't know the angle, or we don't know that given angle, we're then going to go divided by 3 divided by 8. Now this bit here is a bit new. So our job in algebra is normally to get the x by itself, which means we need to move that sign to the other side. And when we deal algebra, we normally deal with opposites. And I guess the question is, what is the opposite of sine? And in our case, the opposite of sine is actually sine negative 1. So we're going to inverse sine x. That means that and that cancel each other out, leaving x. And that's going to leave sine negative 1, 3 over 8. When you put that into your calculator, we're going to have x is equal to by itself. And grab your calculator out with me. Hopefully you can find the sine negative 1 function, 3 divided by 8. That gets me to 22.02. And our units are degrees this time around. I rounded it to 2 decimal points. We've done our first example. Let's now look at our second one. So we've got a plane going up the top here. He better watch out because he might hit that electabuzz by mistake, but hopefully he doesn't. And the angle towards the plane, that's called the angle of elevation. And we're trying to find out what that angle is using trigonometry. We can see our right angle triangle formed from the plane and the ground. And our first step, we need to label the sides of our triangle. So here's the right angle. Opposite to that is the hypotenuse. Here's the given angle. Opposite to that is the opposite. Just a reminder, even though I call it the given angle, it's not actually given to us, but it's the one we're interested in. And the one between the given angle and the right angle, that is the adjacent. Once we've done that, we've got to think about which of the 3 sides we don't care about. And we've got the opposite, we've got the adjacent, we've got no interest in that hypotenuse up there. So we're left with O and A, which would be the toa part of sa, ka, toa. So that's tan. So let's write down tan angle equals O over A. From here, we're going to substitute. So the x, the 400, and the 300, all of them need to go into our equation. So tan x because that's where the angle goes, is equal to the opposite, which is 300, divided by the adjacent, which is 400. We're then going to try to get rid of this tan, and we get rid of the tan by doing tan inverse, or tan -1, of tan x. And because we've done it to this side of the equation, our algebra says we have to do it to the other side of the equation too. So tan inverse, or tan -1 of 300 divided by 400, the tans cancel each other out, leaving us with x equals tan -1, and then 300 divided by 400. Don't forget those brackets there. We're now going to plug that into our calculator, so make sure you've got your calculator out with me. So tan -1 divided by 300 over 400. When we put that into a calculator, hopefully you're getting the same as me, but I'm getting 36.87 degrees, and that there was affected by my 2dp rounding. So hopefully this video makes sense. Key thing to note, this inverse sine, inverse tan, we didn't do a cos example, but cos inverse is a thing as well. That's the new thing we need to know about for calculating the internal angles of right angle triangles using trigonometry. Hopefully you found the video useful. Now let's get into heaps and heaps of practice.